This is an introductory lesson on probability, and the first thing we're going to learn about is representing a sample space. And so first we're going to talk about probability representing a sample space. And at the end of this lesson, you'll be able to represent a sample space for compound events by using an organized list and understand that the probability of a compound event is the fraction of outcomes in a sample space for which the compound event occurs. In other words, it's going to be yes over total. What is meant by sample space? So you're going to take a few minutes and think about sample space. Or you can look up in your document and read the vocabulary, or you can draw a picture right here. Okay, a sample space, the set of all possible outcomes of an experiment. And so if I have an experiment, I'm going to write everything that could possibly happen. Here's an example. Coins is a very good probability question. When tossing a quarter, the sample space is, if I toss a quarter, what are my possible outcomes? If I toss a quarter, it is either going to be a head or a tail. What is a compound event? Okay, think about in English, when your English teacher talks about a simple sentence, subject, predicate, and a compound sentence, which is two or more. So think about how you would talk about a compound event. Tossing a coin is a simple event. One thing I'm doing. Two or more simple events make a compound event. Compound event. Two or more simple events. Tossing a coin, that's an action. Spinning a spinner with equal sectors numbered 1 through 4, that is another event. One event and another event, two simple events, equals one compound event. You toss the coin and spin the spinner. What is the sample space? And you're going to represent the sample space using an organized list. So you can do head and a 1, head and a 2, head and a 3, head and a 4. Likewise, you can do tail and a 1, tail and a 2, tail and a 3, tail and a 4. So here, these are all the possible outcomes of flipping a coin and then spinning a spinner. You represent the sample space using an organized list, and you make sure you list everything. What is the probability of tossing tails and spinning an odd number? So then what you're going to do is you're going to, after you write down your sample space, remember it's yes over total. No, 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 no. Yes on tail, yes on odd. This would be a yes. No, because that's even. Yes. Okay. So I have two yeses. And 1, 2, 3, 4, 5, 6, 7, 8. Two yeses and 8 total possible outcomes. And so what is the probability? Here's my yes. Here's my total. Simplify it. Change it into a percent. I have a 25% chance of getting a tail and an odd number. That's called experimental probability. Now, if I write the not tossing tail and not spinning an odd number, it would be 3/4, because everything is the whole 1, 2, 3, 4, 5, 6 out of 8. Create an organized list to represent the sample space when a fair numbered cube, a dice, is tossed and a fair coin is tossed. So a cube has 6 sides. They're talking about a dice. That's a fancy name for dice. And a fair coin is tossed. Create an organized list. Here it is. Find the probability. and then you circle the yeses over the no's. Now you know about sample space.